Hi friends, welcome back. This is Santosh Kumar. So today we have to start the polar plot, correct? Last time we completed the Bode plot. In the Bode plot we have seen so many gate problems. I hope the concepts are clear now. Okay? And most importantly, the clearance of concept is not enough. I hope that you people started practicing and started revising also. If you are not revising and practicing, it means everything whatever you are learning through this video, you are putting it into the dustbin. Yes, we also have the dustbin in our mind. If we are not going to revise something, not practicing something, after some time, there is some specific time, after some time the mind will put everything in the dustbin. Okay. So according to some scientific studies, we can remember the things only up to the 15 days. Only up to the 15 days. So please, you have to revise it again and again for the, if you want to do well and you want to keep all these concepts in your mind, what you have to do, you have to revise it again and again. And after revising, start the practicing, because you know very well in the last two mirror discussions also I discussed about the practicing, importance of practicing. Okay, so friends, today this is the early morning, I'm recording the video, and today the very very special festival, that is Diwali. So I would like to wish all you people happy Diwali. May your dreams come true, and the next year you people will be, most of you people will be in ONGC, NTPC, HPCL, BPCL, and I'll get the mails. I am selected in this, so my best wishes with you. Friends, actually I'm feeling dull today because this is the early morning, but I'm fully energetic. Okay, I'm really psyche toward the teaching. Anytime, anywhere I can teach, even in the midnight also. So don't worry about that. After some time, 5 to 6 minutes, you will feel me energetic. Means dullness will be over, though I'm fully energetic, more than 100%. You know very well, in the morning, you see, wake up in the morning, the energy level is very high, but dullness is also high. Okay. So let me start the polar plot. Friends, the polar plot, what is the polar plot, right? So I would like to start the session with this. We have covered the root locus, isn't it? In the root locus, the scale was linear scale. Scale was linear. Okay. These points are linearly variable points. If this is 1, this will be 2, 3, 4, like this. I'm just showing. And on the y-axis also, the points are linear. That's why we were getting there. It's symmetrical, isn't it? It's symmetrical about what? Real axis, isn't it? Then we have seen the the Bode plot. In the Bode plot, this is not the linear graph. Why? Because this frequency, this is the log scale actually, and this is the linear scale. On the y it's a linearity, and over here we are taking the log scale. So overall this graph, or the scale for the Bode plot, we are using as the semi-log. Okay, you can see over here this this magnitude variation is linear, 50, 100, minus 50 and 0. But here it's 10 to the power minus 2, 10 times, then 10 times, then 10 times, then 10 times. This is the according to the log function. So this is the Bode plot. But in the polar plot and Nike's plot, the plot is different. Over here the plot is like this. See, we'll see over here the variation in omega, the angle phase variation, and we'll draw the graph. Okay, So the plot for the polar plot and Nyquist plot is like this. Okay, now let me start the polar plot. So what is the procedure to draw the polar plot? Here also we have the procedure. First you will be given with the the transfer function, open loop transfer function. Remember, always for all analysis from the root locus onwards, we'll deal with the open loop transfer function. It doesn't mean that we are not dealing with the closed loop control system stability. Definitely we are dealing with the closed loop control system stability only. What we have done, we have given the relationship we created the relationship between the open loop transfer function and the closed loop transfer function. Whatever you are doing in the open loop transfer function, inside it's going to be or affecting to your closed loop, isn't it? So the open loop transfer function you have in your hand. The first step, find the magnitude and phase. You have to find out the magnitude and phase. Definitely you have to replace the s by j omega first. You have to replace your s with j omega, because all this analysis from the board onwards are the frequency response. So you need omega terms. Okay, so you have to find, the first point is you have to find the magnitude and phase at omega equal to 0. Very important. The second point says find the magnitude and phase at omega equal to infinity. So what you will do, you will get the transfer function, you will find out the magnitude of that and phase of that. In the magnitude you will put omega equal to 0 and omega equal to infinity. Means you will get two magnitudes at omega equal to 0 and omega equal to infinity. For the phi also, for the phase also, you will do the same thing. Then what is the third point? The third point says the ending direction of the plot is given by, see, in the gain margin, when we discuss about the gain margin, we have seen one plot there, and I told you there that we'll discuss this pole or this plot in the next unit, isn't it, if you remember? Okay, so here we have two direction. One is starting direction, the direction from where the plot is going to start. The direction means two things, either it's clockwise or anti-clockwise, two directions here. So we have two direction, one is starting direction, one is ending direction. So that ending direction, how to find that? Ending direction of the plot is given by, it's always given by phi 0 minus phi infinity. Now if you'll ask what is this phi 0 and this phi infinity, so this is phi 0 you already calculated, the second you already calculated, phi 0 and phi infinity over here. What you will do, you will subtract phi infinity from phi 0, you will get some values. If the given values or whatever the value you have found, if that is plus, it means the ending direction will be clockwise. Are you getting? If whatever result you are getting by doing this, and that is plus, means positive, your ending direction will be clockwise. Don't worry about this. When I'll take the example, everything will be clear out. If this is negative, then it will be anti-clockwise. Anti-clockwise. Is it clear? Now if you have ending direction, so definitely you'll be having starting direction also. So starting direction is considered on the basis of negative real poles and zeros. Poles and zeros, but negative real. If the transfer function is like, let me clear, s minus 1, s plus 1, s plus 2. So if you are looking for the starting direction, you cannot consider this part. Means the poles or zeros which are having positive real parts. This is s equal to plus, it will go into the RHS. So you cannot consider this. For the starting and ending direction, you will always deal with the finite poles and zeros. Okay, no problem at all, but that will be negative real, means they indirectly they should be in LHS. This is the foremost point for this. So if you are looking for the starting direction, what you have to consider, the first point is you have to consider the negative real poles and zeros, and these are the finite poles. One more thing, finite poles. Need not to consider s equal to 0. This is not in our consideration. We are dealing with the finite poles and zeros and having negative real parts. So in this condition, if finite poles are near to the imaginary axis, means suppose you have this condition, this type of condition, finite poles. Finite poles are near the imaginary axis. Then starting direction is clockwise. Then if you are drawing the plot, the starting direction should be clockwise. When you have like this, isn't it? Now instead of this, in the second point, if finite zeros are near to the imaginary axis, means the condition is like this. In this condition, the starting direction will be anti-clockwise. So this is the rule for starting direction. For the ending direction, directly what you will do phi 0 minus phi infinity, isn't it? So the next point is the above procedure is valid only if this point is very important, very important. Whatever you are doing, it will be valid only if the magnitude of the plot at omega equal to 0 should be always greater or equal the magnitude of the plot at omega equal to infinity. In this condition only, this entire 6 points are valid, else they will be invalid. If in this condition, it's okay. If you have the condition like, now I'll take it m infinity is greater than m0, this will be invalid condition. Invalid condition means, yes, you may have this, that m infinity is greater than m0, but in that case your polar plot will be not applicable. Polar plot, if your m infinity is greater than m0, वहां पे आपका polar plot हाथ जोड़ लेगा, काम नहीं करेगा. Okay, it will not work there. So let me take the first problem of the day, so everything will be clear to you. So here is the problem given. GHS is equal to 1 divided by S plus 1. What you will do? You will convert it into the frequency domain first. So it will be j omega plus 1. Any problem? No problem. Okay, बहुत बढ़िया. Find out the magnitude now. GH, j omega, you have to find out the two things you have to find out. One is magnitude, second one is phase. So magnitude will be, now I think it's clear to you people how to find out this, isn't it? So this is magnitude. Let's find out the phase also. Okay, we are finding the phase. The phase will be in the numerator 0, the denominator tan inverse omega. So what you have minus tan inverse omega, isn't it? Now according to the first point of the procedure, you have to find out the magnitude at omega equal to 0 and omega equal to infinity. I'll denote this by m now, m for magnitude. So let's find out m0. m0 is the magnitude at omega equal to 0. Here is the magnitude, put omega equal to 0. So 0 plus 1 under root. It means you are getting plus 1, isn't it? So this is your magnitude at 0 frequency. Now you have to find out m infinity, put omega equal to infinity, you are getting 0. The condition is satisfied. m0 is greater than m infinity. Yes, condition is satisfied. The polar plot will work over here. Now let's find out the phase also. Let's find out phi 0 first. Now phi 0 is, definitely it will be 0, minus tan inverse 0, 0. What about phi infinity? Phi infinity is coming minus pi by 2, though tan inverse infinity is nothing but pi by 2, minus sign is coming over here, so minus pi by 2. Now you have 4 informations. You have magnitude at omega equal to 0, you have magnitude at omega equal to infinity, correct? And you have phase values at omega equal to 0 and omega equal to infinity. Now what you can do, you can find out ending direction, you can find out starting direction. These two things you can find out, and ultimately we'll draw the graph or the plot for this. I have to draw the plot, okay? But before that, let's find out the ending direction. Ending direction we were giving by the formula phi 0 minus phi infinity. What is phi 0? Phi 0 is 0 minus phi infinity is minus pi by 2. So you are getting plus. Plus means clockwise. Clockwise. It will be clockwise. Let's find out the starting direction. What you have? You have only single pole, that is the finite pole, isn't it? You have finite pole, and that finite pole is only near the imaginary axis. Who is near the imaginary axis? Your pole is near to imaginary axis. If the pole is near to an imaginary axis, it will be clockwise. So your starting direction and ending direction both are clockwise, isn't it? Now we will draw it. Okay, we'll draw the graph. Let me change the pen. Okay, so omega equal to 0, omega equal to 0, the magnitude is 1. The magnitude is 1. Okay, perfectly fine. When omega equal to infinity, the magnitude is 0. But when omega equal to 0, apart from the magnitude, your angle is, your phase is 0 degree. And over here it's minus pi by 2 or minus 90 degree. So let's draw the plot now. At 0 degree, you have to go to 0. Where is the 0 degree? Here is the 0 degree. Here is plus 90 degree, plus 180 and minus 180 also. Here it's plus 270 and minus 90. So this is minus 270 also. Okay, so the point is at 0, you have to go to 0. Okay, magnitude 1. So at 0, the magnitude is 1. You have to go to 0. Where is 0? Here is 0. Magnitude 1 over here, it will be 0 at this point. And angle is minus 90. Where is the minus 90? Here is the minus 90. Now your plot will start. Starting direction is clockwise. Sorry, starting direction is clockwise over here. Clockwise means in this direction you will move. You will move into this direction. Okay, you are moving. You have to terminate at minus 90, because minus 90 at omega equal to infinity. Your journey will start from omega equal to 0 and always will end at omega equal to infinity. So from 0, if you will start your journey, you are starting at 0 degree. At infinity, you will terminate at minus 90 degree. And foundation is, it should be clockwise. It should be clockwise. Yes, we are starting our journey into clockwise direction. We are not starting to this side, not like this. Okay, and I have to end over here at omega equal to 0, at omega equal to infinity when magnitude is 0. So this is ending direction. This is ending direction. You can check it clockwise. This is starting direction. You can check it clockwise. Is it clear to you? So this is the plot, the polar plot for the particular one. Now let's come to this one. This is for you. See, in the first question, you have only single pole, finite pole. Now in this question, you have two poles. Instead of one, you have two poles. means you are adding this pole extra. So your graph will be like this. Your graph, when you will draw it, this is homework for you. Find it, okay? So you will get like this. This will be the graph for this question. And when you will find out for this, when you have 3 finite poles, your graph will be this. This will be your graph. Okay? So these 2, your homework. These 2 poles or these 2 transfer functions are your homework. Okay? Now observe this. When you have single pole, your graph is like this. When you have 2 poles, means you are adding extra pole. Initially you have 1 pole, okay, that is the reference, and for that particular reference your graph is like this. But when you are adding extra pole, your ending direction is shifting by 90 degree, minus 90 degree. Initially your ending direction was at minus 90. Now it's going to minus 180. Again, if you are adding the third one, the third pole, your ending direction is coming to minus 270 degree. Isn't it like this? It will happen. So the conclusion for this system is addition of each finite pole shift the ending angle by 90 degree in clockwise direction. Okay, this is your let me clear it so it will be clear to you. The addition of each finite pole shifts the ending direction by minus 90 degree clockwise angle. Okay, clockwise direction. So this is the conclusion. So this is all about today's class. In the next class we'll come with some more concepts. Till then, and we'll meet. Wait a minute. Yeah, for the new people who are watching me very first time, for the updates you can subscribe the Gatematic. You can find us on the Facebook for the doubt solution.